So today I want to introduce you to naming. So I know it looks very busy here, but what I'd like you to do is if you have table P, Q, and R out, and if you could take table R out, and if you could add below the fluoro, chloro, bromo, and iodo, the dash CH3 methyl, and then the CH2, CH3 ethyl group. And beside that, I know there's not that much room, but beside that, if you could also just write alkyl. So the halides are considered fluoro, chloro, bromo, iodo, and the alkyl groups are considered methyl and ethyl. And I know you don't know what I'm doing yet, but that's okay. These are called substituent groups. So if you want to pause the video and go ahead and do that, write that in your reference table, that would be awesome. Okay, so moving on. So a substituent group just means that it's replacing a hydrogen on what's called a parent chain. So a parent chain would be something called this right here, which is what I drew, butane, right? So we call that a parent chain. Again, it's but because it has 4 carbons from table P, and it's ane because it all has single bonds. So it's an alkane. So it would be called butane. Sometimes you're going to see something like N-butane. We like to use these big fancy words in chemistry, except for the N, which means normal. So it just looks like a normal butane. I'm not going to use N, but just in case you come across it. So before we talk about the substituent groups, the text, and sometimes you're going to see weird things. Like sometimes butane might be written like that. And it is true to form because they're not just two-dimensional things stuck on a piece of paper. They rotate and flip, and you could also have butane look something like this. But I find that confusing as we're getting into naming, so I'm not going to use that method, but I think there is one question in the homework, so you have to just make sure you count the longest carbon chain, and this actually would be considered the longest carbon chain. Okay, so let's just get into a little bit of naming. So the naming that I'm going to focus on primarily today is with the alkyl groups because the review book does. So what you can do is you can take away a hydrogen. So let me just take away a hydrogen from there. And I'm going to replace it with a methyl group. So just so you know, sometimes methyl is written like that, like the structural form, but it means the same thing as that. Right? So those mean the same exact thing. So that's a methyl group right there. Okay, and you don't have to memorize them because, well, we're remote anyway, so everything is open book. But if you have them on your reference table, you're fine. Okay, so this is a methyl group. So because I replaced a hydrogen with it, I have to give it a location. It's no longer butane. It's a different molecule. So what I'm going to do is I'm going to number the carbon chain. So just like your house number or your apartment number, it's where you can be found, right? So I live on 45 Weston Way. So when someone's driving on Weston Way, they know they can find me at 45. So what you're going to do is you're going to number the carbon chain. So in this case, I'm going to start left to right. 1, 2, 3, 4. And because my methyl group is on my second carbon, that is what I'm going to write first. So 2 dash, and whatever the substituent group is, methyl, and then I write my parent chain butane. So that's how I would name that. Okay, so now say, for example, I go crazy here. Some may argue I'm already there, but... Okay, so CH3, and say I replace, I don't know, this one with a CH3, that hydrogen. So now I have 2 methyl groups, right? A different molecule. So now I would have to give both of them a number. So I'm going to say this is 2, 3. So between numbers, you give a comma, dash, dimethyl, because I have 2 of them, and then my parent chain, which is butane. All right, so say I went even wilder here and I got rid of that one and I put a CH3 there. It can happen. So even though there are 2 on the second carbon, every single one of them needs a number. So I need a number for this one, a number for this one, a number for this one. So this would be called 2, 2, 3 dash trimethyl butane. Okay. All right, let me just give you an example of an ethyl group here because it's in the textbook too. So let's get rid of all these. Let's put a hydrogen here, hydrogen here. Okay, I'm going to put an ethyl group. I used to have a dog named Ethel. Right there. So an ethyl group is a CH2CH3. And they do have propyl, which would be 3 carbons in the review book, but that's no longer tested upon, so I'm not going to worry about that. So that right there is an ethyl group. So you would name it the same way. Give it a number, 2-ethyl, and then the parent chain, which is butane. Okay, so what I'm going to do now is I'm going to introduce you to other substituent groups, which I find easier than the alkyl groups, and those are the halide groups. So the halide groups are, and again, I can take any hydrogen off any part of this chain. So let's go crazy here. Let's put a fluorine here, a bromine here, another bromine here, and let's just say a chlorine here. So I'm going to name this one. Okay, so the way I name this is I name this in alphabetical order, but every single one has to have a number, right? So if I look at my substituent groups here, so I have a fluorine, a bromine, another bromine, and a chlorine. Alphabetically, bromo comes first. So I'm going to give each one of those a number. So 1, 2, dash dibromo, because there's 2. And when we're naming them alphabetically, the prefix doesn't matter. We're just looking at the root, B. And then next I have a chlorine, which would be C in the alphabet, right? So I give that a number. And then lastly, I have fluoro alphabetically. So it's not the numbers that go in order, it's the substituent group names. Excuse me. And then butane. Okay, one last thing I want to talk about today, and then tomorrow we'll do a whole lot of practice. So I'm just going to give you a bunch of names and have you practice them. It's actually quite fun. Okay, so lastly, sometimes you're going to have a lot of substituent groups on the right side of the molecule. Excuse me. So notice how the density is on the right side of the molecule. So because that is the case, we're actually going to count this one right to left. You want to make sure your substituent groups have the lowest carbon number. And remember, they flip over in space back and forth. So it's not like a left to right all the time in the real world, right? They're in liquids or whatever. They flip around. So in this case, it would be 1, 2, 3, 4. The same exact molecule, just written a different way, would be so these are actually the same exact molecule. They're just flipped in space, which again can completely happen. And then you might want to try to name this on your own. So pause it and try to name it on your own. I'm going to name it for you. This is 1, 1 dash dibromo dash 1 dash chloro butane. And if you got that right, that's fantastic. Okay, so homework again is due tomorrow night. You can hand it in or you can submit it as soon as you feel comfortable, but I'm going to give you a little bit more detail tomorrow as well. Have a great day.